Hello! The purpose of this video is to run through a couple of examples in which we solve a system of equations using matrices to demonstrate how row operations work, what's allowed, what isn't allowed, and how to find the solution. So let me review something that I've mentioned before, and these are the permitted operations during the process of Gaussian elimination. There are three things that you can do. You can interchange two rows, you can multiply an entire row through by any non-zero number, and then the last operation is that you can add a multiple of one row to another row. These are the only types of row operations that you're permitted to use. And the way that I am proceeding right now is to just do row operations and not column operations. Later we might discuss a perspective where we take column operations, but for now let's work only with row operations. So when we interchange two rows, that means we would take something like row I and send it to row J and send row J to row I. Multiplying an entire row by a non-zero number is pretty straightforward. And then we're going to be adding multiples of one row to another row. Now there's a variety of ways that you can do this, but I'm going to look at Rule 3 in a very particular way. In all of the examples that you will see me do, I'm going to be doing a row operation of the following form. CRI plus RJ is going to go into row J. In particular, if I have a multiple, a non-zero multiple of one row, that's going to be the row that is not the row I am replacing. This coefficient, the coefficient of RJ, is a +1, not a -1, and not any other multiple. The reason for doing my row operations in this constrained way is going to become more apparent later when we record elementary matrices and are interested in calculating their inverses and things like that. But this is just the way that I'm going to do it right now and the way that I recommend that you do it. So let's get on to our example. We're going to be solving the system of equations that's written here. There are three equations. We now have an x and a y and a z. We're going to be looking at x plus 2a minus 2y minus z equals 1, 4x plus 9y minus 3z equals 8, and minus 2x minus 3y plus 7z equals 10. Well, the first thing we're going to do is package this into a matrix. It's going to be a lot easier if we don't have to write down all those x's and y's and z's. Having packaged it as a matrix, I'm now going to start the process of Gaussian elimination, and I'm going to do this with a strategy. So this first number that I have highlighted in blue is called a pivot, and this pivot is equal to 1. Now I'm going to use my pivot, and I am going to use it to clear out the row underneath it. My strategy is that I am going to start with this pivot and I am going to clear downwards, and after I have cleared downwards, I am going to clear going to clear towards the right. So you're going to be seeing me clear this 4 and then clearing the -2 first. So the row operation that's going to turn that 4 into a 0 is going to be if I take -4 row 1 plus row 2 into row 2. I am using a row operation of the explicit form CRI plus RJ into RJ, and in particular I'm replacing row 2. So I'm going to carry that out, and I have the matrix 1, 2, -1, 1. The first row does not change, and the third row does not change. The only row that changes is the middle row, and it becomes 0, 1, 1, 4 after applying this row operation. I'm going to keep using 1 as my pivot. So I still haven't cleared out the first column, and so I've gotten rid of the 4, but I still haven't gotten rid of this -2. So the next row operation that I'm going to use is targeted towards the third row. And the combination that I want now is going to be 2 row 1 plus row 3 into row 3. When you're deciding what row operation to use, you can ignore the parts of the matrix that are to your right. The only thing that you're focusing on right now is using the pivot to clear away the entries that are underneath it. And then the rest of the numbers just become whatever they become. When we do this particular row operation, the first row is unchanged again. And now the second row will be unchanged, 0, 1, 1, 4, but it's the third row that's affected this time. Following the linear combination, we see what happens. In the third row, we get a 0 as desired in the leftmost spot. In the next spot, we have a 2 times 2 minus 3, giving us a 1, and then we get a 5, and then we ought to get a 12. So what we've produced now is a column that looks like 1, and then all zeros underneath it, which is good. I'm going to straighten this out a little bit, 0, 1. Now, the next thing that we want to do is keep moving down and to the right. Our stair step has formed thus far, so now our pivot changes. The next pivot that we're going to use is the one that appears in the second row. This is going to be the pivot that kills the one underneath it. So we're going to use this to eliminate the one in the third row. The appropriate linear combination that we're going to need is going to be this one. We're now going to take minus row 2 plus row 3 into row 3. And after we do this, 1, 2, minus 1, and 1 are still in the first row. 0, 1, 1, and 4 are still in the second row. And the third row becomes 0, 0. And now our 5 is going to get replaced. We have a minus 1 plus 5 giving us a 4, and a minus 4 plus 12 giving us an 8. We have actually achieved something that is in echelon form. The last row operation that we're going to do is just to convert this last entry in this entry 4 here into a 1. So we're going to divide this row through by 1/4. So 1/4 row 3, giving us a very nice matrix that looks like 1, 2, minus 1, 1, 0, 1, 1, 4, and 0, 0, 1, 2. We have a matrix which is in row echelon form. From here you can observe that there are 3 pivots where the leading coefficient is equal to 1 and exactly 3 rows and columns. So that's enough information for you to see that there's actually just going to be one solution. We have our pivot, and our pivot, and you could solve for it from here. But what we're going to do is do more row operations to put it in what's called reduced row echelon form, where it would be even easier to see what the solution is. We're going to need a little bit more space in order to work towards that solution. So let's just borrow this elimination process and put it on the next page of notes. So where we left off was with this last matrix. 1, 1, 1 down the diagonal. And we're going to work with this one. We know that the z-coordinate is going to be given by the last row, but we're going to do further row operations to make it extra clear what the y and x coordinates that we're solving for ought to be. So before, our strategy was to clear down and to move rightwards as we cleared down. Well, now our strategy is going to change a little bit, and now we're going to be clearing upwards. And in particular, we're going to be starting with the lowest pivot, and we're going to be using it to clear above. And instead of moving down and right, we're going to be moving up and left. Our strategy flips when we get to the bottom of the echelon. So our first victim is going to be this 1 that sits in the second row. And the row operation that we're going to use to eliminate it is minus row, we're going to use minus row 3 plus row 2 into row 2. And upon doing that, the first row is unchanged. The third row is unchanged. But that second row is going to become 0. Notice that the 0 remains a 0. And this 1 also remains a 0. But this is now going to become a 0 as desired, and in the last entry we're going to have minus 2 plus 4, giving us a 2. Okay, great. Next, we're going to use the same pivot. Our pivot was the 1, and our pivot is still this 1. And we're going to eliminate the other entry that sits above it. We're going to be eliminating this negative 1 right here. We're going to do that with the row operation that just adds them together. So this row operation will be row 3 plus row 1 into row 1. So 0, 0, 1, and 2 in the third row, and 0, 1, 0, 2. The second row can stay as they are. And now our first row is 1, 2, 0, and then we have a 3 showing up. There's one more thing that we need to do because we have this little 2 that needs to be taken care of. So now we'll be using this middle 1 as the pivot and eliminating the 2 with the following row operation. Minus 2, row 2, plus row 1 into row 1. After which we'll have a very nice looking matrix. 0, 1, 0, and 2, and 0, 0, 1, 2, and the second and third rows are unchanged. And then our first row is going to become a 1, a 0, a 0, and then minus 2 times 2 is minus 4, plus 3 giving me a minus 1. So from here it's super easy to read off the solution. You have to do almost no work. You get here the equations that just read off the solution. So in particular you get x is equal to minus 1, y is equal to 2, and z is equal to 2. And that is the solution.